Hello everyone, I am Dr. PSV Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I'd like to explain a brief talk about the introduction of lasers. So at the end of this lecture, students will be able to understand the characteristics of laser light, and also they can learn the interaction of radiation with matter. Now coming to what is a laser. Basically, laser is an acronym of light amplification by stimulated emission of radiation. It is actually a light source. Generally, we have so many conventional light sources, then why should we go for laser light? And what aspects is differ from conventional light? That what we are going to discuss now. So actually coming to the characteristics of laser. So there is a monochromaticity. Laser light is highly monochromatic, not only single colored but also single wavelength, whereas the conventional light is not perfectly monochromatic light. Coming to the directionality, laser light is highly directional. It travels only in one particular direction without divergence, whereas the conventional light spreads in all directions. Intensity, laser light has very high intensity. For example, the intensity of the laser beam, suppose that is having 1 milliwatt output laser, say, that is nearly 10,000 times to the intensity of the sunlight on the earth surface. That much intensified light that laser light is. Whereas coming to the next one, coherence. Laser light is highly coherent, perfectly coherent light, whereas the conventional light is not that much coherent. That means two waves are having same amplitude, same frequency, maintaining constant phase difference over an infinite time and distance. Here, laser light is perfectly coherent. These are the characteristics of laser light, or these are the distinctions between the light from the lasers and the conventional light. That's why we are going for the laser light production and applications. So, what are the characteristics of laser light? It is highly monochromatic, highly directional, and it has more intensity, and it is perfectly coherent light. These are the characteristics of laser light. And coming to the interaction of radiation with matter. So generally, the most important the topic in the laser light is the interaction of radiation with matter. Radiation means light, whereas the matter means material. What are the interactions between light and the matter? There are actually three types of interactions. One is absorption, next spontaneous emission, and stimulated emission. These are the three interactions between radiation and the matter. Coming to the absorption, simply when the light is incident on the object, on the matter, we don't say that it is absorbed. There there is some condition for this. That means whenever photon of energy h nu is incident on an atom, then the atom will go to the excited state. This process is called absorption. When photon energy h nu is incident on an atom, in that atom actually the electron absorbs the energy and it will go to the higher energy state. This process is called absorption. So, in the form of equation we just write like this: any atom A plus h nu that gives rise to A star. So, photon energy h nu is incident on the atom A, and the atom goes to the excited state, means in the atom the electron goes to the excited state. So, this atom is said to is taken as A star. The atom is in the excited state. Generally, atom in the excited state cannot stay for infinite time. It cannot stay for longer time or infinite time. After its lifetime, the atom should come to the ground state. Here, suppose this is the atom in the excited state. Atom is in the excited state means the electron is in the excited state up to its lifetime. For example, hydrogen atom, say I write this as H star. The lifetime of the hydrogen atom 10 power of minus 8 seconds. After 10 power of minus 8 seconds, what happens? The atom on its own, it comes to the ground state by emitting a photon, h nu photon energy. So, in the form of equation it is written as A star gives rise to A plus H nu. A star, the atom is in the excited state, that gives rise to atom and A, and that releases a photon H nu. So, the same thing is explained here. The atom is in the excited state. After the lifetime, the atom comes to the ground state by emitting a photon on its own. We are not doing anything, we are just waiting up to its lifetime. That is why this process is called spontaneous emission. Suppose we do not want to wait up to its lifetime. So, within the lifetime, suppose a photon energy h nu is incident on the atom. The atom is already in the excited state. Now, the photon energy h nu is incident on the material, on the atom. That atom is already in the excited state. So, what happens? This incident photon will stimulate the atom, will provoke the atom. As a result, what happens? That atom comes to the ground state by emitting photon. Already incident photon is there and this photon. So, how many photons will be released here? 2 photons are released with the same frequency nu and same phase. That is why the light emitted during this process is coherent. So, this is the most important mechanism or important feature to get the laser emission. Once again, just saying, already the atom is in the excited state. It is actually about to come to ground state, but within the lifetime, a photon of energy h nu is incident, and this is stimulating the atom. As a result, the atom is coming to the ground state, emitting 2 photons at a time. This process is called stimulated emission. Incident photon is stimulating. As a result, atom is coming to ground state, emitting 2 photons at a time. You observe this equation. A star means the atom is in the excited state, incident photon h nu, and this gives rise to now the atom A means it comes to ground state. How many photons are emitted in this one? 2 photons are emitted to h nu with the same frequency and phase. This process is called stimulated emission. So, that is why there are 3 interactions between the radiation and the matter. What are the 3 types of interactions? Absorption, spontaneous emission and stimulated emission. So, after the absorption, the atom can come to the ground state either spontaneously or stimulatedly. Spontaneously means we have to wait up to its lifetime. So, after some time, atoms will come to the ground state emitting the photons. But here, the light emitted is not coherent. At different times, different places, the photons are emitted. That is why this light is not at all coherent light, it is incoherent. And whereas stimulated emission, after its lifetime, means before the lifetime, the incident photon is stimulating, 2 photons emitted at a time. So, the light emitted during this process is highly coherent. So, in this one, means in the basics of lasers, what we have discussed is the characteristics of laser. What are the characteristics of laser light, or in what way it differs from the conventional light source? Means the laser light is, say, highly directional, highly coherent, it has more intensity and monochromaticity, means all these are the special characteristics of laser light. And afterwards, in this one we have just discussed interaction of radiation with matter. What are the interactions between radiation, means light, and the material? 3 types of interactions we have discussed. One is the absorption, the spontaneous emission and stimulated emission. These things we have covered in this one. Thank you. Thank you very much.